Houston, we have a problem. We want to solve this problem here. We got a man picking up a suitcase with weight S. So he's pulling up a suitcase, but if you read it carefully, he's not able to actually pick it up. So it's still touching the floor. So as you're solving this problem, I mean, you're supposed to like determine what forces are acting on it. It's multiple choice, but so he's got the weight of the force of gravity pushing down, right? And since it's still touching the ground, there's a normal force. Now the normal force, since he's already pulling up, will not be equal to the gravitational force, because by him pulling up, so you have a second one going up. This is the force of the pull, if you will, of him pulling up. And so the question is, how could I find the normal force? Maybe a way to think of this is to draw this like this, because this force of gravity has to equal, so this height has to be equal, if you will, because they're all in one dimension, in the y dimension, have to equal this. So if you can figure out what force he's pulling up, you can figure out his normal force, if that makes sense. It's a simple, I'll let you figure it out. The sum has to add up to 0 since they are not moving. So if they're not moving, the sum has to add up to 0, and then you can solve the problem. And then the second half of this question, he's sitting on the suitcase. Again, draw one of these free body diagrams. Now in this case, remember, there is the force of gravity of the man and the force of gravity of the case pushing down. And so what would the normal force be pushing back up? Again, remembering that there's no motion. So the force down has to equal the force